Now we're going to look at shape. So we're going to compare the shapes of our data. Now when we say compare our data, we're talking about the literal data points. So if we have a look at our box and whisker graphs here, you can see that I've drawn these lines over the top. Now they're very, very rough, very kind of squiggly, but they give us the general shape. Now, we use some very particular language when we talk about shape. We've got some vocabulary down here. We could be talking about unimodal data, bimodal data, no modality, uniform, irregular. All of that is talking about how many peaks, how many high points we have in our data. So if we have a look here, we have many, many high points, but if we look at the shape, it's actually one sort of uniform shape here. Okay, so that's talking about the fact that we've got a very flat top is uniform. We can look at this one here and we notice that it goes up, 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 and there's a highest point, one mode. And that's what we talk about modality, is talking about the mode, most common. You should have heard that from year 11. So when we have unimodal, uni like unicycle, it's got one mode. And bimodal, like bicycle, has two modes. When we have no modality, it's because we have a very kind of squiggly shape and it goes up and down, up and down, up and down, up and down. None of these here kind of have no modality. These would be described as more uniform, irregular, or unimodal if we have a look at all of these. This one here may be considered bimodal because of the flat section in the middle. We can also discuss our data in terms of symmetrical, or it could be skewed to the left or skewed to the right. Skew is literally talking about where the data tails off to. So you see the tail of this, it means it's being pulled. The data is being pulled up to the right-hand side, and here the data is also being pulled up to the right-hand side. This one here, the data is actually being pulled down to the left-hand side. So when we have identified which of our, what each of them are, we need to be able to put these into sentences. So we can see here that the afternoon data is uniform but skewed to the right. The data tails off to the right-hand side. It's also called positive skew because that's the positive side of the graph. The morning is unimodal. I'm sorry, that keeps popping up. The morning is unimodal and is also skewed to the right, and because the left is where the peak is. Okay. When we look at the smart dog, we have very little data. It appears symmetrical, but it's difficult to identify the modality with such a small amount of data over the large range. Okay, so we can identify that it looks skewed and it's possibly bimodal for the small dogs, but it's difficult to tell with such a small amount of data over a large range. Okay, so when we have large amounts of data like we do for windy morning, we can quite easily tell the modality and the symmetry of our data. When we have a small data set, as you can see, there's only 49 and 51 pieces of data in these over such a large range, we can't accurately identify the modality of these. We can, however, put these into sentences, and you'll have access to these data, so the video won't be in the view. You'll have access to these slides, so that it won't be in the view, and you'll be able to see exactly how to write about these. But it's mostly showing that the data, so for our windy morning, the data shows that there is no most common afternoon wind speed in northern Dunedin. Instead, the speed is uniform between 0 and 5 meters per second, with a few readings above 5 meters per second, meaning the data is skewed to the right. The morning data has the same positive skew, but we can see that it is there is one highest peak at 2.6 meters per second, making the data unimodal. So what I'm doing is I'm comparing the two whilst also identifying the features. We can identify in Smart Dog that there's not enough data in either group to show the general shape of the intelligence ranking for small and large dog breeds, but the intelligence ranks of large dog breeds does appear to be more symmetrical at this stage, whereas the intelligence ranks of small dogs appear to be skewed to the left. Okay. And then what does this indicate, which is what it's hiding, is that this indicates that more small dog breeds struggle to follow commands and learn new skills. More data in each group would give a better shape and more information. So as I said, you'll have access to these slides, so you'll be able to see how to analyze shape